Jai Hind everyone. Myself Amrita Tiwari, Assistant Professor, Ajay Kumar Garg, Engineering College. Today my topic is on mode of transfer, that is direct memory access. Let us discuss what are the outlines of my PPT. So firstly we will see what introduction of input-output interface. Then we will see different modes of transfer. Then we will see what is actually a DMA is. Then we will see a DMA controller, and lastly merits and demerits of DMA controller. So firstly we should understand what is input-output interface. So the input-output interface is an essential component in a computer system. It enables communication between CPU and various external devices. These external devices are peripherals like keyboard, monitor, printer, and storage devices such as hard drives, network interface, etc. So basically, input-output interface is something that that helps in communicate between the CPU and the our peripheral devices. Like this is our CPU, and it has its system bus. In system bus, we know it has data bus, address bus, and control bus. So to communicate with this system buses, we have interfaces like this. We have interfaces, and with this our devices, our external devices are connected like keyboard, monitor, and so on. So every devices has its own interface, because in every devices has its own function. The function of what keyboard do cannot be done by the monitor, or what monitor do cannot be done by the keyboard. So every devices have their own interface. It's like a hardware circuit. It's like a circuit. So let us understand how the keyboard, or we can say how the devices are communicate with the CPU and the memory, that we call as a mode of transfer. So what is mode of transfer? The binary information that is received from an external devices is usually stored in the memory unit. As we know, the communication between the CPU and the devices, the external devices, whatever we read or write, we have to store or we have to fetch the data. We need a memory unit. The information that is transferred from the CPU to external device is originated from the memory unit, and CPU merely process the information, and the target is always the memory unit. As I said that the target is always the memory unit. CPU merely process the information, but the source and the target is always the memory unit. So the data transfer to and from peripheral devices may be done in any three possible way. So there is a three possible way how we can do a mode of transfer, that is programmed input-output, interrupt driven or interrupt initiated input-output, and lastly DMA. We will discuss this in briefly, but we should understand what is in program input-output and interrupt-driven input-output. In both, the involvement of CPU is must. So, if it is our memory, it is our CPU, and it is our input-output devices. So, if the input-output devices and memory unit wants to communicate with each other, the CPU is an intermediate between them. So, in programmed input-output and interrupt-driven, the CPU is the intermediate part, but the DMA, direct memory access, as the name itself say, directly communicate with the memory unit. The input-output device and memory directly communicate with each other without the involvement of CPU. So let us discuss in briefly how they work. So firstly, we will see a program input output. So in a program input output, let's suppose there is one flow chart. Firstly, CPU will issue the read command to input output. So it will issue whether the input output is ready to have a read command. Here, the read status of input output will be checked by the CPU. So here, when up to here, the CPU will be in a loop unless and until it gets the OK. Now the input output is ready. The status is given to a CPU that input output is ready. CPU will idly wait, simply idly wait. So here, in this part, the CPU is kept busy. So CPU can't do any other work. So here, the CPU work, or we can say CPU is work is paused. When the status is OK, then it will come here and read the data, unless it will be in this loop only, and this loop also known as polling. When it get the right signal that input output is ready for the read, then the data is read from the input output. Now input output, the read data will go to CPU. Now CPU have to store that data in memory. So again, the write data will be performed. The write data will be performed, that is, it is written into the memory. Then we will check all the data is transferred. If it is transferred, then it comes out of from here, from this, and go for the next routine. If not, it will go up again, and then again will issue the read command, and again will wait up until and unless the input output device give the status that he or she is ready for the read. The disadvantage here is the CPU is kept in a loop. This disadvantage is overcome by the interrupt driven. So in interrupt driven, what happens, once the read issue command is given to input output by the CPU, it will not wait. Here it is kept waiting. Here it will not wait. What will CPU do? CPU takes up some other work, and input output interrupt the CPU with the status. So here the CPU have not to be wait for the read status. He will do some other work. When the input output is ready, he will go and tell the CPU that I am ready. Then CPU come back. So then CPU will come back. There will be an interrupt. Then again here the read the same process that we do in a program input output. It will be done. The data will be read from input output. Then we will write that data into the memory, and if the work is done, it will come out from the flow chart, or it will go above and then again check the read status. So in both program input output data transfer and interrupt driven input output data transfer, here the CPU is kept busy, but it's overcome by here that the CPU will do other tasks. But again, the involvement of CPU is there, because the read data from the input output, it goes to CPU, and CPU again then write data from the memory. So here the involvement of CPU is there. CPU is still busy in the read and write data of the input output devices and the memory. The communication between the input output device and the memory, CPU is still is an intermediate in both. So to overcome this part, we use the concept of DMA. So let us see what is DMA. So direct memory access is a capability provided by some computer bus architecture that enables data to be transferred directly from the attached devices such as disk drive to the main memory on the computer's motherboard. The microprocessor or the CPU is freed from the is freed from the involvement with the data transfer, speeding up overall computer operations. As the name says, direct memory access, so it will directly communicate with the memory without the involvement of CPU. So how it works? Suppose there is CPU, there is DMA controller, it is memory, and there is an input output device. So firstly, input output device will ask for DMA controller. He will ask for the DMA control. I want to talk to the memory directly. So he will it will request. So now the DMA controller, what he will do? He will request, bus request for the CPU that give your bus to me so that I can communicate, I can make the communication directly between the input output and the memory. And in this, CPU will grant the bus. The bus means it's system bus, the control of all its buses, address bus, control bus and data bus will be given to DMAC. Now DMAC, what will he do? He will acknowledge that I have get the buses. Now you can directly communicate with the memory. So this is the working. This is the overall working of the DMA. How it works? DMA firstly request for the system bus from the CPU that grant me your system bus. When the system bus is given, granted to DMAC, then input output device and memory can directly communicate with each other. So after that, when the communication is over, the bus request is disabled and bus grant is written back. There will be an interrupt and the control of system bus, that is data bus, control bus and address bus will be given back to the CPU. So this is how the DMA works. Let us see what is the overall function of the DMAC, how it is made. So this is the overall working of the DMAC controller. How the DMAC controller works? You are seeing there is an address bus that stores the address of the data. There is a data bus that stores the data of the data. There is an address bus buffer and data bus buffer. What is the function of address bus buffer? It temporarily stores the addresses that comes from the address bus, temporarily stores. And what about the data bus buffer? It temporarily stores the data that comes from the data bus. You are seeing there is a control logic. What is the control logic? There are so many inputs. Firstly, there is DS. What is DS? DS is the DMA select. When the DMA is select goes up, means when the unit go 1, that means the control DMA is on. Now the DMA can work. There is one register select RS. You can see there are 3 registers: address register, word count register and control register. So what are the functions of this register? Address register denotes the address of in the memory where the data is. We have to read or write, we have to perform the operation of that particular location. That's the address. What is the word count? The number of read or write operation we have to perform, the number of data, that's the count of that word, number of word count. And control register means what will be doing in that with that data. Either we are reading that data or we are writing that data. That tells us the control registers. Again, then we have read and write signals. Then we have bus request and bus grant. So bus request means it will be goes to the CPU for the request of the buses, that is data bus, address bus and control bus. When the CPU grants, then the signal is become 1 and the DMA controller will be on. There is one interrupt. Interrupt means when the all the working has done between the memory and the input out devices, all the communication is done, then there will be an interrupt, means then CPU can take over their system bus. So there is one important thing. Let's suppose address, register and word count register. So in address register, suppose the starting address where we want to read or write data is 1000 and the count is 50. So first in location 1000 and the world count is 50. Again next address will be 1001 and the count will be decreased to 149. Again next address will be 1002 and the world count will be 48, and so on. The world count will be counted up to and unless we get it to till 0. When the world count is 0 means the work is finished. So from this we can say address register increased by 1 and the word count register decreased by 1. So that's the overall working of a DMA controller. Let's see. So let's have some overview. So DMA control register have 3 registers: address register, word count register and control register. The function I have already told you. So the CPU analyzes the DMA by sending the given information through the data bus, the starting address of the memory block where data is available to read or where data is to be stored, means to write. It also sends word count, which is the number of words in the memory block to be read or written. Control to define the mode of transfer such as read or write. What we have to do, this control register. Again the control to begin the DMA transfer. So there are different types of DMA transfer mode also. There are basically 3 types of DMA transfer, but the main is cycle stealing mode and a burst mode. So what is cycle stealing mode? Cycle stealing mode or means a single mode or a byte mode means DMA controller obtains access to system bus as in a burst mode. To transfer 1 bit of data and return the control of the system bus to CPU. So in cycle stealing means transfer of only 1 data at a time. Only 1 data is transferred at a time. When the 1 byte of data is transferred, the control of the system bus is given back to the CPU. So basically in cycle stealing, it is generally done by the slow devices like keyboard, monitor, where we have to send a 1 byte data or a less amount of data. Whereas in burst mode or a demand mode, the entire block of data, the entire block or a chunk of data is transferred in one continuous sequence. Once the DMA is granted access to the system bus by CPU, it transfers all the bytes of data in the data block before relinquishes control of the system buses back to CPU. Means it gives all the transfer it at one, all the block of data, whereas in cycle stealing 1 byte of data at a time. So it is bus data is mostly done by that are very fast processes like magnetic disk, which are very fast, which can do. So this mode is very useful for loading the programs or data files into the memory, but it keeps CPU idle for relatively a long time of data because it is sending the entire block of data. So for sending the entire block data, the time is needed. So it is a time consuming method. But in DMA, 1 byte of data is to be transferred. So the time is not that much as compared to the burst mode. Let's see some advantages and disadvantages of DMA controller. So data memory access speed up the memory operation and data transfer. As we know, it speed up because there is no involvement of the CPU. There is a direct communication between the input-output devices and the memory. DMA, very few clocks while transferring a data. DMA distributes workload very appropriately. DMA helps in CPU in decreasing its load. So it is the main function of DMA controller to use is it decreases the load of CPU, whereas in program input output and interrupt driven, the involvement of CPU is there, so the load is there, the CPU unnecessarily is kept busy. In DMA, there is the DMA told CPU to give its system bus to it, and the CPU is freed from it to be engaged in the in the read or write operation between the input output devices and the memory. But there are some disadvantages because so DMA controller is costly in operation because of the additional operation we do. DMA suffer a cache coherence problem. This is the main problem. Cache coherence problems. DMA controller increase the overall cost of the system and also increases the complexity of the software. So according to Wisely, we use the different types of mode of transfer when is to be needed. Either we using a program input output or interrupt driven, where there is a small amount of data to be transferred, but for the large chunks of data, or when we see that CPU is getting more engaged, we can use the DMA. So act accordingly. We choose between these three types of mode of transfer. So that's all for today. Thank you.